Now we have to move. We have to move for a matter of time to the next speaker. Starting the session about ethical and legal governance for data sharing and AI in cancer imaging. And I would like to introduce Davide Zaccagnini. Is a former vascular surgeon. He has been researching clinical decision system, data interoperability, privacy for large-scale data ecosystem for more than 50 years. His research started at MIT and is continuing now at Linkaeus, a private research center, where he is currently serving as managing director. So, Davide, please, you are welcome to start your presentation.
Thank you, Emanuele, and welcome everyone to this webinar. I will start by giving an overview of what are the main topics on the table today regarding the ethical and legal frameworks that are under development after the GDPR came into force in 2018, both in Europe and globally, as of course the communities of researchers and R&D teams focusing on AI is not limited to our continent, but of course spans into US and Asia. And my assessment so far is that while the European regulation, both on the legal and ethical side, has definitely broke ground that many other jurisdictions are following, the problem in Europe is not necessarily legal or ethical anymore. The frameworks are in place. The understanding of how these frameworks could be implemented are clear. What is really still happening in our continent is the actual implementation of these principles and regulations in infrastructures, in data ecosystems. As I was also referring to, this is not only a European trend. There is, of course, the need for transnational and transcontinental collaboration in research, and that is definitely an area where instead the gaps in regulations and common frameworks are still very present, as I will explain in a minute. After these frameworks will be hopefully established and integrated, of course, we will be left, as we are today, with a problem of incentivizing data circulations. There are many reasons why today, even in presence of good laws and clearly implemented legal requirements, data are still not circulating the way they should. And part of this resistance comes from the uncertainty regarding the uses of data, especially AI, and how AI is going to really redefine both the ethical and professional processes that are taking place in clinical care. So this is just an illustration of what, from our standpoint, are the main topics for discussion or the main issues on the table, and then going one by one, starting with the implementation of LC requirements in actual data ecosystems or infrastructure. There is a specific process or approach that has been very successful so far in addressing the implementation of these requirements. The privacy by design method that is now becoming commonplace is indeed successfully delivering platforms that are compliant, that do implement GDPR principles and the ethical correspondence around data exchanges. What is probably still lacking in a way is just the knowledge and the habit of implementing a privacy by design process as these platforms are created. In essence, what that would entail is to treat legal and ethical requirements the same way technical requirements are treated during R&D operations. So as it happens for the technical design of platforms and data flows and use cases that really define how the data are treated, how they're exchanged. So the legal and ethical requirements can be really treated and folded in the same process. The correspondence between technical and legal teams is happening more and more, and legal teams are engaged in the early stages of definitions of these platforms, guiding the design to respect and enforce GDPR principles. And as a result of these early engagements that we are actively applying in EuCanImage and other projects, the result is that you can set the goals of what is another major step in the compliance assurance, the DPIA, the privacy impact assessment step. You can set the goals of that process up front. DPIAs are not enacted in a void. You need to understand first, what are you really assessing in terms of what use cases, what type of scenarios you want to test the compliance of your system into. And that is indeed something that starts with the privacy by design process, when the technical and legal requirements are folded into the same process of definition and specification in an iterative fashion. So what is the point I'm trying to bring here is that there is really more of a need for really getting used to these practices rather than gaps in definitions or legal frameworks, at least for what pertains to the European context. The other good news regarding the compliance of European data ecosystems is that we are now looking at a technology landscape that is really delivering the right type of tools and solutions to make these systems compliant from a legal and ethical standpoint. In EuCanImage, we are implementing a variety of these solutions. Secure multi-party computation, which is a system that distributes and encrypts queries that are executed on federated data system, is a way to keep not only secure, but also, if implemented in the right way, private the output of these queries. In itself, secure multi-party computation doesn't guarantee privacy because it's a
and distributing the queries so that no single data owners can access other data sets without permission, but it can also be implemented to also constrain what each of the participants in the SMPC network can actually see from others' data. This can be done by writing queries that mask the actual underlying data and provide only results, aggregated results to the users. But it can also be done by integrating differential privacy into the query themselves. Differential privacy injects noise into the queries so that the output is actually verifiably private. Depending on the amount of noise that is injected in the queries, you can actually quantify the risk of re-identification in a given output for a given patient. SMPC can be integrated with blockchain, and this is also something we are going to do in EuCanImage. Blockchain, as most of you probably know, has this quality of being immutable and public, and being used to record and represent all the transactions that are actually happening in the data ecosystem. In itself, it serves as a ledger, as a record of these transactions, but there is more that can be done with it. And as these technologies mature, these opportunities for actually additional value in the area of legal and ethical enforcement are coming apparent. One of these qualities that if every query that is executed on a given data set is tracked, then you can also look back and understand how much times a given data set has been queried and by how many users and who are these users. What that allows you to do is to track a privacy budget. You can understand that if many queries by the same user have been executed on the same data set, then you're facing a risk of some private information to be revealed. And that is one of the emergent paradigms that blockchain, as it's integrated with our technologies, is allowing to really leverage, on top of the ability to track the provenance of these data assets. Of course, this can happen within the ecosystem, but it's still helpful as a way of controlling that people are not reusing data in ways that they shouldn't. The other tool that we're bringing to the table in EuCanImage, as Karim was mentioning, is synthetic data. This is a very powerful way of not only, as it was discussed before, to supplement the underlying data sets on which AI systems can be trained. That's, of course, one of the main uses. But the beauty of synthetic data is that they're also anonymous by definition. There is no identifiable information in synthetic data because they are actually created by different type of AI algorithm in the generative process. That allows, for instance, to expose statistically meaningful data sets that do not contain any specific information of underlying patients. And that in the process of exploring the possibilities that a given data set might allow from an R&D standpoint, whether it's traditional research or it's AI development, synthetic data definitely present a very strong solution. And they can be developed, again, for a more explorative type of use, all-purpose type of synthetic data, or they can be created for for specific tasks. We are now in the process of looking at requirements for synthetic data that will be used to train AI algorithms for lesion segmentations, automated lesion segmentations, especially in mammograms. So that's also a very interesting development. All I'm saying here is that compared to a couple of years ago, when all these technology were just making it to the attention of the research community, the landscape has substantially changed. We do have now tools that are really ready to be applied and making data exchanges compliant, secure, and private in the European legislation. What is challenging, though, is the transnational and transcontinental data exchanges. I will just go quickly here to point to the fact that while there are provisions in the GDPR for exchanging data across at least some non-European jurisdictions, we have some substantial problems regarding the actual definitions of privacy across these different jurisdictions. The idea of anonymization, which is widely used, or de-identification, which is widely used in the US, for instance, and it's one of the pillars of the GDPR as well. If you actually look into how these different regulations define what is anonymous and what is not anonymous, you end up seeing substantial discrepancies. There are actually different frameworks and assumptions on which these frameworks are based. That is indeed one of the main challenges that we are facing as we try to exchange data with the US, with Asian countries, and so on and so forth. Just to give you an example, the definition of anonymization that is provided by the GDPR is very generic and purposely so. The GDPR legislators wanted to not specify too many details, but leave both the technology and the research community free to identify that remaining set of definitions and technological solutions that were going to bridge the gap between the principles of the legislation and the actual application in reality. So they kept it fairly general, and they gave only broad indications compared to the US approach. you see just the sheer amount of detail that the HIPAA regulation actually includes. I'm taking just a snapshot of that definition. The actual definition is way longer than that. And it really goes into the details of what needs to be removed from the records, listing each of the identifiers or quasi-identifiers, plus providing different alternative method for carrying on the identification and so on and so forth. So this discrepancies in the principles governing the legal landscape in different jurisdictions remains a big problem. And there are fortunately also in EuCanImage a lot of initial discussions that try to tackle this problem and create the interoperability that is needed to exchange this data. I'm not expecting this to be entirely resolved by the end of our projects, but we are definitely actively looking into create a framework at the very least on which, for instance, transnational contract and data transfer agreements can be based. Now, as we move into the logic of data exchange, once we have the regulations, once we have the technology to implement the regulation, the other part that is missing is the incentive to share data. This is a big topic both in the academic environment, but also in the commercial environment. And the problem underlying all this discussion is that data are non-rival goods as economists define them. You can copy data as much as you want in an infinite number of instances without incurring in any cost. This is what a non-rival good is, meaning everybody can possess the same amount, the same type of data without multiplying the cost or services that are needed to create these copies. What this does is it really flips around the whole economic concept of supply and demand. You have infinite supply. And this is also, even if you consider just the academic side of this problem, this is really the problem. Every academic center knows that if the data that they spend so much time in collecting and curating and then publishing on, if the data is shared, you just lose control because of this inherent quality of the data. And that is indeed a problem. And a lot of work is done on finding economic models that can apply to the data. There are very important works that are happening in the pure economic space. The problem with those works so far is that it's really hard to compute a function that specifies this value of a specific data set in correspondence in relation to all the other data sets that could have similar content, for instance. So in assuming this very hard theoretical problem as one of the causes of still the lack of incentive frameworks that really motivate people to share data, we have indeed, on the other hand, the tools and the actual abilities to very practically, without necessarily recurring to very sophisticated economic model, we have the tool to actually empower data owners with the ability to assign value to their data, and with that have the level of comfort that they need in order to be more proactive in the sharing of these data. Indeed, with SMPC, for instance, you can really control who's accessing your data, for what purpose, as the blockchain informs the system in terms of what are the permissions that you have set for your data. You can understand how many of these data are actually accessed and how much information is really retrieved from your data. All these dimensions of what is actually done and how much value are you giving to third parties that are accessing your data can be expressed, can be made explicit to data owners so that they can then make their own judgments in terms of how much am I expecting in return from this access to my data, whether it's maybe financial, rewards or just recognition or opportunities for collaborations. What I'm trying to express here is that while the absolute data value of data cannot be established, the practical aspects of making your data available can activate a semi-economic type of landscape where data owners can collaborate with data users in a way that is informed and not and allows them to keep control over their data assets. Now, moving on with the last issue that we are facing in EuCanImage, all this makes sense, but has to be looked into the perspective of training medical AI solutions. Now, there is, of course, a lot of emerging research that is done in the area of medical AI. The issues are many. They range from the safety of AI systems to the ethical directions of these AI systems. The European Commission came up recently with a framework for regulation. There are no actual regulations, is only at a level of establishing some general principles that classify AI in 4 different categories, from the unacceptable ones that just are dangerous and harmful to people, to the minimal risk ones, such as spam filters or similar type of low risk type of solutions. Well, medical AI, and especially imaging-based AI, is in the 3rd category, so the high-risk ones, which basically means that any artificial intelligence systems that comes out of such type of projects like EuCanImage will have to undergo formal approval from the regulatory agencies, the European Medicine Agency or the FDA in the US. This is actually good news because on one side, the processes that these agencies require to walk through are very well established. They're the same or roughly the same that apply to medical devices. And they provide a substantial and very predictable process to actually bring AI tools to the market. The more complex problem is that you may still be infringing on ethical principles. The tool could be working perfectly well in terms of diagnostic accuracy or the ability of classifying patients, but the problem may still be very serious on an ethical standpoint. There are many papers and experiences that have demonstrated how AI can have systemic biases in terms of gender issues or racial issues. And in cancer imaging, that's definitely an emerging problem, as diseases are not distributed equally among genders or races. And the balancing of the populations that should be starting not just at the level of training the AI algorithm, but at the level of identifying the population itself and making sure that the underlying training data sets are balanced and non-biased. That is in itself, it's a very substantial problem and area of research. The other aspect is assuming that the AI algorithm actually works very well, the question still remains, if there is actually a mistake in diagnosis, who is liable? Should you able to sue an AI algorithm? Would the physician be able to say that he was relying on the AI algorithm and it's not his fault? Those are all open questions that we will be looking at very closely during EuCanImage, with the idea of coming up at least with a conceptual framework that is process oriented, so not just principles, but actually looking at how things happen both in the development of the AI algorithms for oncology and also in the clinical decision-making process. And with this, I conclude my presentation, and I thank you all. If you have any question, I'll be happy to answer.
Okay, thank you. Thank you very much, Davide. So I think now we should move to the panel discussion. In the meantime, I don't see questions from the attendees. If there are some coming, I will address them to the panelists. And I would like to invite, of course, Davide as panelist. Also, we have Magdalena Kogut-Czarkowska from Poland. She's a lawyer. If I suppose you are a lawyer. She worked 40 years as a lawyer in the APC Tech team of Baker and McKenzie in Warsaw, one of the largest international law firm. So it's obvious that we need a lawyer to discuss these topics. I would like also to invite Marius Meyerhofer. I don't know if Marius is online.
Yes, I'm online.
Hi, good to see you, Marius, from the ESOI board. Professor Meyerhofer is professor of radiology at the University of Vienna, actually in the Sloan Kettering Center in the United States. So welcome, Marius. So just to stimulate the discussion and taking advantage from the presentation of Davide, I would like to ask you, maybe as more a technical question, what do you think about the effect of blockchain in this? You already mentioned, Davide, how in blockchain will change the rules in the privacy of patients and so on. What's your opinion in general, the opinion of all the panelists about blockchain, this setting, especially in the development of the large repository of a EuCanImage project? I don't know if, Davide, you want to start, and then we will go to the other.
Yeah, so it's a topic very dear to my heart, because my group is very much invested in that developments, and this is also to say that I have some bias. Of course, I'm very much a fan of the concept of distributed technologies in general, of which blockchain is an example, but there are others. I think in essence, what these technologies will bring to the table soon is the ability of aligning interests that so far in healthcare have been not only not aligned, but actually in opposition. Healthcare in general, when it comes to creating data ecosystem, is a very distrustful type of sector where, you know, research centers really want to hold on to their data, but there are other players who are looking for these data, but nobody really trusts each other. And I think what blockchain does is, without necessarily changing these relationships, allowing at the same time data flows to happen in a private and secure way, resolving the underlying issue of the whole sector. And that is done in multiple ways. One is, again, creating immutable public records of what transactions are happening. The other way in which this happens is that in these exchanges, you can automate a lot of the administrative process of data sharing and remove the subjectivity, the sort of personal interpretations that go into these type of transactions. For instance, if I set my data access policies, these data access policies are going to be true and executable for anybody, regardless of what I personally would like to do. And that is, to me, a very important step toward a really transparent and efficient data sharing ecosystem.
Thank you, Davide. Magdalena, what do you think about that from the legal point of view? I know there are many laws in Italy that are lawyers in Italy that are taking care about blockchain. So it's of a great interest for you.
Yes. Thank you very much for the invitation here, just saying hello to everyone. And to jump right into the question that you posed, indeed, blockchain technology is a very powerful tool. It has many upsides, one of them being that it's a secure ledger. It cannot be modified, so when a transaction is recorded, it would not be possible to disturb this record and to falsificate it. But on the other hand, there are some downsides or challenges that have to be also considered when we are talking about such projects as medical image repositories. I myself am involved in another project from this cluster, so an Incisive project, which also will build a medical repository, and we are also looking at the blockchain technology as a tool that will help to record the transactions and the access to the data. And of course, that can be very helpful. But on the other hand, because what is put in this ledger, it would not be able to be erased in the future or deleted, that can have downsides from the perspective of privacy. So generally, under the GDPR, there's a very powerful right of the data subjects to request that your data be erased or the right to be forgotten. Of course, it's not an absolute right, but it does apply in certain circumstances. And that's why you need to be very careful when implementing that kind of technology into repositories, as to not include any actual medical data in the record, because then it may possibly not allow this data to be removed when necessary under GDPR. So I agree, it's a very helpful technology. It does help to manage and track the access to data in the context of these repositories we are talking about, but also there are some restrictions that need to be applied. So it's a powerful tool that also can have some downsides.
Okay, thank you, Magdalena. Marius, what do you think about the impact of this technology in the radiological environment? Or if you can foresee the impact?
Just of the blockchain or generally of the data sharing? Because the data sharing, obviously, I mean, that is basically the foundation to obviously develop meaningful AI models. I think the really interesting question is what kind, at least for the different centers, what sort of revenue they will be able to generate from sharing, so that they will actually willing to participate. Because as we've heard, and if I understood correctly, EuCanImage allows both data sharing for generation of knowledge, so basically for the public cause, but also for financial revenue. Is that right? Is that the concept behind it?
No, actually,
no.
In my presentation, I was giving more an overview of the general state of the art in terms of data exchanges, but EuCanImage is strictly a research type of platform, and there is no exchange of value. I was again referring to the bigger problem, because in a way, I think, Marius, you're right. There is, even if it's hidden, and even if it's paid by research grants, there is a cost in generating data, and therefore there should be, in theory, I would say, a return for those who work on the generation of data. And as I was saying, this is a very hard problem, because with non-rival goods, that return is really hard to calculate what it should be. But no, I mean, there is no monetization of data in EuCanImage.
Because at some point, of course, that I mean, we all know that the big tech companies are all interested, and actually, especially in the US, have put a lot of effort in getting to those data. But I mean, even in the academic sector, the revenue will sort of have to be regulated, for instance, including author rights for use of the data. If that can be somehow standardized, I think that many institutions would be much more willing to share their data, because at the moment, I think most institutions see the data that they have, and of course also especially imaging data, as a sort of treasure. So they will try and keep those data safe, and that will of course hinder research collaborations, at least in the way that when there is public access to data repositories, again, I think institutions will not be willing to contribute at least the majority of their data. They might contribute subsets, but yeah.
No, I think these are great points. Just quickly, to add some color to them. If you look at some of the economic models that are emerging regarding the value of data, it's easy to see that sometimes data are really the biggest economic asset of any given organization. Sometimes 80% of the evaluation of a company or an institution is their data. On the other hand, it's really hard to put a price on data, but I think again that in a way the GDPR actually opened that possibility, and Europe is really at the forefront of these studies, because in reality, if you have a way to control privacy, you have also a way of controlling how much information is actually released to a third party. And in turn, you have an easier time. You don't have a full solution, but you have an easier time to calculate how much that information is worth. And with the technologies that we have in place, again, blockchain is one, SMPC is another one, differential privacy is another one. We are not there yet, but I think we have a good toolkit for really starting that discussion.
If I may also add from a legal perspective, or maybe a governance perspective, the European Union is currently also very much interested in encouraging and even mandating further data sharing for research purposes, so-called secondary purposes of the use of data. And these projects like the European repositories are really in the eye of the storm when it comes to different new subjects that are on the political agenda. So AI Act, which was mentioned earlier, is one of them, but another act that is also being prepared is Data Governance Act, which is precisely about opening up data that is already sitting in different institutions, and in particular within the Data Governance Act, there are supposed to be created so-called data spaces, and one of the first data spaces that the European Commission would like to create is the European Health Data Space. So to enable and to trigger the exchange of the health data, and also to address the problem that was mentioned, that there is really no incisive or no instrument to put it bluntly, force hospitals or different institutions to share the data which they already have, and to incentivize them to share this, but also to do it in a way that is privacy preserving, and that this data is really used for meaningful research rather than for uses that do not help the society and do not help the European citizens as such. So I think the European health data space initiative and perhaps a regulation or a directive that the European Union is working on is definitely something that we need to look at when considering our projects.
Okay, in this setting, the General Data Protection Regulation is not helping us because, as Davide mentioned, the anonymization process is not clear, no? Because they say that the data should be no longer identifiable by all subjects. But the problem is that when we share the data, we would like to know which patient has been shared. So we would like to come back now with a pseudo anonymization, and there is a lot of discussion about whether or not pseudo anonymization is correct or not. There is a question from our attendees. I would like to address this question to you all. You mentioned general issue related to potential gaps in the database with regard to race and gender. I think Davide showed one slide about this. Are there other demographic considerations you are keeping in mind specifically for Europe, considering its diverse population and unique collection of histories? Maybe Davide, you can start. Let's see.
Sure. Well, age is definitely another dimension of possible biases. AI algorithms that are trained on images that come from a population of a given age might very well underestimate the risk of that disease in a different age group. Younger people, for instance, are typically underdiagnosed by even human radiologists because the incidence in these categories is lower, so they don't expect to see those type of diseases. The same could happen with AI tools. So yeah, that is definitely another area that comes to mind. The different ethnicities, I think. If you want to look at the broader picture, one way to mitigate all this is to have what we are trying to do in EuCanImage, which is not just train algorithms on only images, but to have a different underlying data set that includes not only different imaging modalities, but also other types of data, including genomics and clinical data. To me, that is probably the safest way to really create the statistical robustness in AI agents.
Yeah.
There is, unfortunately, a strong limit in terms of how many type of images you can get, but adding other types of data should mitigate the potential bias that you get from one data source only. And also, of course, the federated learning paradigm allows you to train AI agents not only on one database, but on databases that come from different geographies, different specialties, different type of populations, and do your best up front. Of course, then you need to have a strong validation to make sure that these biases are not there despite your efforts, because they could be.
Maybe I address the questions to Marius because it's more, let's say,
so
clinical.
I think one way to do it, at least in the academic sector, and that's something that I hadn't seen in my former workplace in Vienna, but that we have in place in the US, is basically even at the level of the study design, there is already the demand to take into account diversity, racial diversity. So even when planning your original cohort in a prospective study, you need to meet a certain level of diversity. That's probably one way to address the system. But then again, as has been mentioned before, we will never, depending on the geographical region, probably never reach a full balance in terms of diversity. So that is, of course, where the testing of established algorithms that, let's say, are developed in the EU they need to be tested on basically global populations and other data sets. And that is exactly where the data sharing comes into play. And that's why it is so important to also enable this internationally. I mean, of course, within the EU, that is the first and necessary step. But looking forward, that is a global issue.
Yes, and we had the example of this, or the diversity of data in the setting of pandemic. You remember at the very beginning of 2020, when after the first wave in China, a lot of, let's say, AI tools came into our hospitals with proposals from companies from China that were, let's say, dealing with us if we wanted to use this software with the European patients. And so there has been a lot of concern because these tools have been trained with Chinese patients that may have probably different body composition, different behaviors in terms of the diffusion of the disease. So, and the problem came up, of course, with a very specific use case, but the pandemic was raised up this issue of the diversity of data. And I agree with David that this data must be stratified with the patient characteristics, so the clinical data, the age, the race, and so on. And that's why we are building biobanks. That's why we are getting and developing these projects that have exactly the scope to build multi-omics data in order to stratify the patients and combine radiological and other omics data. So